Hello, we are Team Comet Me Bro. I'm Kelvin.
I'm Adam.
And I'm Willie.
Our goal is to make an autonomous research companion. More specifically, as an input, we'll take a natural language description of a data collection space mission, and as an output, we'll have a robot autonomously execute this mission. And why are we doing this? The first reason is that astronauts are scientists and not roboticists. The second reason is that astronauts might have limited cognitive bandwidth. And then the final reason is that manual execution is prone to errors, and autonomous execution will help limit some of those errors.
So for our solution, we've built a pipeline that turns natural language into autonomous execution. An example would be an astronaut saying, "Go scan that rock formation, take a sample, and then return to base." The idea is that the astronaut doesn't have to specify super low-level behavior. They can specify mission directives to the robot. So our pipeline starts with text input from the user, which is then given to our LLM-based mission planner. The sole purpose of this is to take the text input and return an action plan, which is a specific set of actions for the robot to accomplish, and this is sent to the robot to be executed. This pipeline allows the astronaut to focus more on high-level behavior rather than the detailed actions that the robot must take.
So our design actually incorporated quite a few unique features, including a full AI pipeline that we accomplished using a fully custom LangChain agent implementation that was integrated with OpenAI/ChatGPT. And our platform also has omnidirectional vehicle control via four-wheel drive Mecanum wheels. And basically we have a ground station application that runs separately that actually communicates wirelessly. The commands that we send off to the cloud that get processed by the AI agent get communicated as low-level commands back to the robot through our pipeline over Wi-Fi, and they're processed on board by the ESP32 chip. And we accomplished all of this using only available supplies given to us through the inventory room. Apart from a portable charger that we use to power the thing, and some nylon standoffs that we provided for ourselves.
All right, so now I will be demoing our pipeline. This is our robot, this is our user interface. I am able to specify the mission prompt in plain text. So to start off with something simple, I'll type out, "Hi, please move forward 1 meter, then turn right and move forward another meter." We'll submit this, and the LLM mission planner automatically generates a plan, and the robot begins to execute it. In the user interface, you can see the mission progress as it is completed. So now, just to show the power of this system, I will give it a much harder prompt. So we'll say, "Hi, first move forward 1 meter, then turn right, wait 2 seconds, move forward 3 feet, jump into the air, turn left, take a photo, move back 1 meter." So this is a significantly more complicated plan, so it'll take a little bit of time to generate it. But this should showcase the fact that the LLM can process this in plain text and handle it appropriately. So it automatically can convert feet to meters, it can filter out impossible tasks, and overall allows the user to not worry about the low-level details, instead focusing on the higher-level goals.
All right, so I'll talk about the onboard hardware on a robot. Everything's running on an ESP32 in here. We have 3 ultrasonic sensors and an IMU, and some omnidirectional wheels, Mecanum wheels, that allow it to strafe left and right.
And I did a lot of work on the ground station, so this is just a UI that's built in Pygame, and here you type in your prompt similar as you would on any LLM, and we're just sending it to the OpenAI API. and then it takes the task and discretizes it into tool calls, and then we have this nice layout here showing exactly what the task is.
Yeah. All right, so now we'd like to talk a little bit about the potential of this product. We're really proud of what we've gotten done in the last 30 hours, but there is so much more we could do with this in the future, so much more that it is capable of. Willie, if you'd like to talk about it.
Yeah, in fact, we've hardly even utilized the hardware that we have and the sensing that we have on here, and we're still able to accomplish all of this and this proof of concept given our limited time and resources. But given much more, everything hardware-wise is plug and play. We could plug in more hardware and develop more software on board to communicate with upstream through the pipeline, and add more functionality.
Yeah, and so some examples of higher level behavior that we've discussed would be like some form of localization or mapping the environment. We were really hoping for a LiDAR sensor, but weren't able to find that. But we want to emphasize that the LLM model planner and the action plan system is already very powerful and is all ready to accommodate a lot of these higher level behaviors. And so we're very proud of what we've done this hackathon.